Hello everybody, I'm Eric Smith. I'm a online student and I'm going to talk to you about Hypertexture, or my final project from hell. What you see before you is an example of Hypertexture. Hypertexture is a 3D procedural texturing technique invented by Ken Perlin in 1989 originally, I believe. It actually won him an Academy Award, whereby you use volumetric rendering combined with a density calculation and a noise function to get really cool visual effects. As you can see here, you have an egg that has had its volume carved out by a hypertexture. My goal was to get a fireball much like this one. This again uses hypertexture to modify the look and feel of a basic sphere. So I've used a lot of big terms so far. Let's see if I can explain to make hypertexturing a little easier to understand. The first thing that you need to know is that hypertexturing is based on volumetric rendering. Volumetric rendering is where you actually have a mathematical equation to represent your object. You do not have polygons and triangles, what have you, sent down the bus and rendered on the Z-buffer algorithm that we're accustomed to. What you have here is a sample from my fragment shader of volumetric rendering of a sphere. The sphere is represented by an outer and an inner radius. We'll explain in a bit why there's two radiuses. And every time that a 3D point is evaluated, we check to see if it's within the sphere. So that's the first thing to keep in mind. We're rendering volumes. So how do we render volumes when we're in a Z-buffer place? The first is a technique called ray marching. Everyone here is probably familiar with ray tracing. Ray marching is somewhat similar without the bouncing. It's also very similar to ray casting, if you're familiar with that. We cast a ray from the eye through a plane and we take steps. Now the difference between ray marching and ray casting, at least as far as I can figure, is that we go through the object. As you can see, these little white dots go each step along the way, allowing us to calculate the density of the object at that point. And we do this until we reach a density of 1, which means we stop the ray. I keep talking about density. What do I mean by that? Well, hypertexturing depends on the idea of soft or fuzzy objects. So instead of rendering a pure sphere, or instead of thinking of a sphere as a location and a radius, we're going to think of it as two radiuses. One that goes out to the end of the soft section and one that is the inner radius, that's the hard section. You can kind of think of it like a baseball, which has the outer sort of shell, and on the inside has a hard piece of cork. If you look here in our volumetric rendering, in an effort to get the fireball, the inner radius is 0. I was apparently feeling thorough when I decided to do 0 times 0 to make sure I got 0 squared. Alright, so to sum up what we have so far, you'll need volume-based rendering, not polygon-based rendering. You'll need to implement ray marching to do this. You will not be able to use traditional Z-buffer. And finally, you will need to calculate the density of a volume at each step. Now, we're using it with an example of sphere. The other one has, the other picture had an egg. This has actually been done to do things like cloth and smoke. You can sort of imagine how that might be. Now, how do we render, where do we apply the hypertexture? What do we use to apply it? Well, typically we use a noise function. I'm sorry that I don't have a better picture, but Perlin noise, invented again by Ken Perlin, who invented hypertexture, is a type of pseudo-random number where the values will go between -1 and 1, and the distribution will follow kind of bell curve, where about 60% of the values are kind of in the middle. There won't be as much on the outskirts. So you get a pattern that's kind of like this, and you can modify frequencies and amplitudes in order to get sort of nicer looks. So in the example of the fireball, you'll see that we're actually going to change the color to be either transparent, change the opacity, and then we're also going to add some darker reds to get those sort of brown looks. Or at least we're going to try to. All right. So how did we do this in Render GL? Well, written a volume shader. Volume shader just inherits from the GL SL shader, and it projects. When you specify volume shader, it's going to immediately ignore any vertices you've sent along with it, and instead is going to change the projection mode to orthographic and draw a square from -1 to 1 across the entire screen. It's also going to add texture coordinates to each corner. This will make sure we get a fragment shader call for every single pixel on the screen. Keep in mind your blend function, you want to make sure it's alpha 1 minus source alpha, or you won't get any transparency. The vertex shader is pretty straightforward. We're gonna want to specify the sphere location and view ray here. I'm doing the model view projection matrix right now and following the ray along the projected ray. Really don't want to. I want to do the eye coordinates, but every time I attempted that, I ended up with a black screen. So we are doing projection. The ray marching algorithm. Now, here we go through. This is in the fragment shader because 90% of the work for this is in the fragment shader. We step through each one, each step size after we've cast our ray. We'll go through each step and get the density. So you can look here and see that the total alpha, when it reaches 1, we're going to bounce out of the loop. Or if we've gone through 100 steps, which should be more than enough for what we're doing. We calculate a density for that point in the ray. We compute the color based on where the ray is and the density. We then do attenuation. I've tried both this attenuation, which is specified in the reference material for Hypertexture, and I've also tried the attenuation we used in class. This one worked a little bit better and should keep our densities to be between 0 and 1. Finally, we integrate that value from front to back and continue along the ray. Right. The density function, this should look really familiar, but it should make a little bit more sense. We're using a sphere. Now there's many shapes you can use for hypertexture, but the sphere is the easiest starting point to start playing with, and we want to make an explosion. So we go through each step in the ray, we see where the point is, we see if it's in our fuzzy land, which it's either in the fuzzy area or it's not, and it's black. And then we compute the color.
So, computing the color. Computing the color becomes pretty simple once you know where the point is and where the density is, at least in the example I have here. This is one of several different color computing methods I've written as I've been experimenting with hypertexture. In this case, I'm just modulating the green value based on the density and the red value based on the density. We'll see a couple examples of this at the end of this presentation. Finally, the noise function, and just say no. GLSL has a noise 1, noise 2, noise 3 function, all of which will compile. None of them will run on my video card. They don't seem to run on any commercially available ones, or very many commercially available ones. But the internet could be lying to me. I don't have a series of machines sitting at home to test it on. From what I read, ATI and NVIDIA do not support it. I have attempted to write several different variations on Perlin noise, including Perlin improved noise, and been completely unsuccessful. So the examples I show you will be doing things like the random that I just showed. Okay, this is my first image. To call this hypertexture is kind of glorifying it, but I'm going to do it anyway because we are changing the color based on the density of the sphere. Hence the reason it changes color as it goes towards the middle. We're changing from green to orange, really to closer to a red, but we're never completely letting go of green. I use this as a beginning point to try and get to a explosion. The next picture, it's much more orange. In this case, I'm actually removing any green where the red is 0. So you can see now I've got kind of a glowing orb, but it looks a little bit more like a Nerf ball than it does an explosion. Unfortunately, because my noise functions don't pass, and because I only have 6 seconds till I'm up to 10 minutes, I can't really explain any further. other than to show my last slide, which actually just uses two crude random numbers to give you an idea what could be done with hypertexture in addition to the better examples from the inventor that are shown earlier. Here, it's probably hard to see on a projector, but in this circle, I've put some random sprinklings of green color, which gives it sort of a almost a clothy like it's a koosh ball or a hacky sack or something texture. Alright, now that's my presentation on hypertexture. I hope you guys were at least able to learn something. Are there any questions? No? Alright, well thank you very much.